When working with half-life, it's important to understand what half-life is. So before we can begin this worksheet, we need to have a working definition of half-life. Half-life is the time it takes for 1/2 of the material to decay. And so half-life is measured in units of time. So units could be seconds, they could be minutes, days, years, something along those lines, but it has to be a unit of time. Now, if we look at this graph that we have right here, okay, it talks about the radioactive decay of iodine 125. Now, remember that iodine 125 is an isotope. We have the element iodine, and the mass specifically is 125. Now, if you look at the periodic table, you might see something a little bit different for the mass, and that's because the mass of this isotope will change depending on the number of neutrons. Okay, but it's important to really analyze what the graph looks like and what it's saying. So if we look at our y-axis here, we see that the mass is on the y-axis, and mass is measured in grams. So anytime they're asking you for how much or something along those lines, it's asking you for a question in grams here. But on the x-axis, we have time in days. So we can see that our unit for these particular questions will be days if they ask us for anything related to time. So we see that at 0 days, we start off with 600 grams of material. We can just follow up the line and look at the unit where it's measuring with this little draw here, and we see that we have 600 grams. So if at 0 days we have 600 grams, then we know that our half-life, according to our definition, is how long it takes for 1/2 of the material to decay. And so we say to ourselves, okay, well, half of 600 is going to be 300 grams. So we look at our graph and we find grams on our y-axis, 300, and we go to the line. 300 is right there. And if we follow that down to the x-axis, we see that that lines up with 60 days. So it takes 60 days for it to go to 300 grams. So that means my half-life, abbreviated this way, is equal to 60 days. Remember that my half-life is equal to a unit of time, not mass. So our half-life is not 300 grams, but it's the 60 days that it took to get to the 300 grams. So if we look at problem number one asks us what percent, so we know they're looking for a percent as our answer, of iodine has decayed if 5 half-lives have passed. Now we know that 60 days is 1 half-life. So how many days has passed if if 5 half-lives have gone by? So if we say 60 days times 5, we get 300 days. So if we look at our chart, we see 300 days right here. We go up and we see that there is 18.78 grams remaining. Okay, that's how many is left over. We started off at 600, and over 300 days, a certain number has decayed, and we only have 18.78 grams remaining. But they want to know how much has decayed. So how much has already left? Okay, if they asked us what percent is remaining, we could turn this into a percent here. But they want to know how much has already decayed, how much has already left. So what we need to do is we need to do a little subtraction problem here. We say, okay, our 600 grams that we started off with minus our 18.78 grams will give us, we need to do a little math here. We're going to have 10, 2, that'll be a 9, Um, 5, 1, 8, 5, 581.22 grams. Now, I should have my calculator out, but I didn't, so I was doing that mental math. So if I was wrong, double check me and change my answer. But that is that's how many grams has decayed. But we want to know our answer in a percent. So what we need to do to turn it into a percent is say 581.22 grams divided by the initial 600 times 100 will give us a certain percent. And I managed to find my calculator just now. So 581.22 divided by 600 times 100% will give us 97% decayed. Okay, that means a majority of this compound is already gone. Let's look at problem number 2. Problem number 2 says if 3 half-lives have passed, how many grams of iodine 125 remain undecayed? So that's important. We know that there are 3 half-lives have gone by, and they want to know how much is undecayed or how much is left over. So we can say, all right, 3 times our 60 days gives us 180 days. So if we find 180, it's right here, we go up and we have 75 grams left over, which is exactly what they wanted to know. We didn't have to turn it into a percent, and we did not need to know how much was already gone. They wanted our answer in grams, so we give them our answer in grams. If we look at problem number 3, it says what fraction of iodine 125 has decayed if there are 37.5 grams left over from the original sample. Okay, so now we need to know kind of what's going on. They want to know a fraction. So we know that there is 37.5 grams left over. Okay, but they want to know the fraction that has decayed. Well, if we take our 600 and subtract our 37.5, we can figure out how many grams have already passed by. So 600 minus 37.5 will give us the 562.5 grams that have left over. And in order to put this in a fraction, we would need to simply put it over the total amount. So 562.5 grams divided by the initial 600 grams, and it is in fraction form exactly the way they asked us for it. If we look at problem number 4, it says if 130 days have passed, approximately how many grams of iodine 125 will remain? So again, now we have 130 days have gone by. So we find 130 days on our chart, and 130 days is, I don't know, somewhere around here, more than 120, but less than 180. And we know that they want to know how many grams is remaining. Okay, so we're not going to have to do any subtracting there. So if I just kind of go up to here, follow my line, I see that it's less than 150, but more than 100. So why don't we just cut it in half, around 125 grams. Now that's not an exact number, but it is an approximation based on our graph here. Let's look at problem number 5. Problem number 5 is what is the half-life of iodine 125? Well, that's easy. We've already figured that out. We know that the half-life of iodine 125 is 60 days, okay? Our one half-life. It's not a trick question there trying to mess you up. We know that it takes 60 days to go from 600 grams to 300 grams. So let's just continue on here. All right, so if 315 days have passed, how many grams of iodine 125 will remain undecayed? So now we're looking at 315 days. Now if we look on our x-axis, 315, I don't know, somewhere around here. Now, it's a little more difficult to make this estimation, but we know it's going to be less than 18.78 and more than 9.4. So we can just say around 16 grams. Notice that I'm not trying to add any decimals or things like that. I can't estimate to that level of accuracy, but I can give a roundabout whole number answer there. You should not have any decimals in that answer. Now, if we look at problem number 7, we see that problem number 7 wants to know the mass of iodine, so we're looking for our answer in grams after 6 half-lives. Now, we know that our 1 half-life is 60 days, so 6 times 60 is going to give me 360 days have gone by. So, if we look for 360 days, oh, lovely, it's one of the numbers already there, we see that 9.4 grams is remaining. But they want to know how much has decayed. That means I'm going to have to subtract. So if I take my 600 grams initially and subtract the 9.4 grams that I got from the chart, I will have 500 and, well, let's make sure that I do my mental math correctly. 600 minus 9.4 is going to give me 590.6 grams. So I now have my mass of how much has already decayed. Let's look at problem number 8. Problem number 8 says how many grams of iodine 125 have decayed away if 12.5% is remaining? Well, we know that if 12.5% is remaining, that 100 minus 12.5% will give me the amount that has already passed by. So if we do that math problem, we will get that 87.5% has already decayed away. And now we need to figure out, okay, well, what is 87.5% of our initial 600 grams? And we do that by multiplying 600 grams times 87.5%, which when you take it out of a percent would be 0.875. We multiply that number in order to get our final answer. So 600 times 0.875 will give us 525 grams have decayed. All right, so we did that by figuring out what percentage has already decayed and then multiplying that by our original quantity of iodine. If we look at problem number 9, it says what fraction of iodine 125 remains, so we know we do not have to do any sort of subtraction here, after 300 days have passed, and they want our answer to be in a fraction. So if we look for 300 days right here, we see that we have 18.78 grams remaining. And in order to put that in a fraction form, you have to put 18.78 grams divided by the initial 600 grams of iodine that we started off with. Okay, so we put our answer in a fraction form. Now, if we look at number 10, it says how many half-lives have passed if 1.2 grams remains. Now, we can see that 1.2 grams is right here on my chart, and if I count how many half-lives have passed, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 half-lives have passed because the spacing in between every single number on our y-axis, or excuse me, our x-axis is 60 days. So it's just really able to count the spaces. We could have also confirmed that by saying 540 days, 540 days divided by 60 would have given us 9 half-lives. And they want to know how much has decayed. Well, if my 1.2 grams is what is left over, And I know that 600 minus 1.2 grams gives us our remaining answer. And it's very important, guys, especially on your test, don't try to do mental math unless you know you're really good at it. Because making a silly mistake just because you didn't want to use your calculator would be tragic indeed if you got the answer wrong. But it will give us 598.8 has already decayed. So it's very important for your test that you be able to read a graph and answer these sorts of questions about them.